This tutorial will teach you how to solve an equation by using factoring. So all of our equations today will be some type of binomials, and the factoring we'll be using will be either GCF or DOTS, difference of two squares. So if you're following along with the class notes, then you're going to write this in your table of contents on the appropriate page. And if not, we'll just continue on with the lesson here. So the learning target for this lesson is that you can solve an equation as long as it says it's equal to 0 by using factoring. So these are the 4 things you need to know in order to be successful. 1, you need to know how to manipulate an equation to make sure it says equals 0. Then you have to factor using either the GCF or the difference of two squares. Once you do that, you're going to use your multiplication property of 0 to set up 2 separate equations, and we're setting up 2 because we're dealing with binomials today. And then you have to be able to solve an equation by isolating that particular variable. So let's take a look at this multiplication property of 0 that I was just talking about. So I have some examples written here on the screen, and the first example says that 3 times the quantity x is equal to 0. Well, if we know that the answer is 0, then that must mean that x has to be 0. Because the only way for you to have a product of 0 is for one of your values to actually be 0. Now, certainly we could use some division property of equality here to prove it, right? To prove that x is 0. But we don't want to use all of that math today. We just want to understand the rule, and the rule states if you have 2 factors and their product is equal to 0, one of those factors must be 0. So that's pretty obvious here that the second factor is 0. Now how about the second example? Well, if this one is 5, then it can't be the 0 factor, so this one must be the 0 factor. But what about my third example? I have the product of the letter x and y, and the product is 0. Now can you for sure certainly tell me what the value of x and y both are? And the answer is no. The only thing we do know for certain is that either x is 0 or y is 0, or maybe even both. But we can't be sure. One of them, though, has to be equal to 0 because that is what the 0 product rule says here. So we're going to use this rule to kind of help us out today to solve some of our problems. So this rule states that if the product of two quantities is equal to 0, then at least one of those factors has to be 0, right? So if I have the quantity x times x minus 5, then either this one would be a 0 value or this one would be the 0 value, right? So I need you to understand that it either is going to be this factor or it's going to be that factor. Because what we're going to do today is we're going to split our factors into 2. So the first thing you need to do is be sure that there's an equal 0 at the end. Second, one of your sides should be written in factored form. Third, you're going to split the problem into 2 parts. X is equal to 0 is one sentence, and x minus 5 is equal to 0 will be your second sentence. And then you're going to solve both equations. So let's just get started. So if x times x plus 3 is 0, then either this one must be equal to 0 or this factor must be equal to 0. So you see what I did just there? I separated my 2 factors, right? Factor number 1 and factor number 2. I separated them into 2 separate equations, right? And now this one requires no work at all. Either x is 0, and this one requires a little mental manipulation here. I bet you could do it in your head. And the answer is -3. So I have 2 potential answers. I don't exactly know which one it is, but I do know it could either be that the value of x is 0 or the value of x is -3. And when we have 2 possible answers, we generally write our 2 answers in ascending order, right, from least to greatest. And we put these fancy braces around it. You could put the x in the front like this too. Right? So let's just prove that. If I put a 0 here and a 0 here, would that be equal to 0? Yes, 0 times 0 plus 3 is equal to 0. Now what if I put a negative 3 here and a negative 3 there? Would that be equal to 0? Well, negative 3, and then my quantity here would be 0. Yep. So it works. All right, let's take a look at another example. All right, do you have an equals 0? Yes. Do you have factors? Yes. Then you're getting right to the splitting stage. Either this one is equal to 0 or this one is equal to 0. Now you must show me this step on your paper. You must show me that you understand that this multiplication property of 0 is what is going to give you these two separate sentences. Now from here, the amount of work you show is optional. For most of you, you can do this math mentally, and you know that this one would be 0 and this one would be positive 6. Right? Now, could you show me the inverse property? Sure. But for most of you, you can do this in your head. So I'm okay with you skipping that step, as long as you don't make a mistake. Get your two answers set up, and that's it. That's how you solve an equation by factoring. Now remember, it only works if there's a 0 here. All right, let's try this one more time. I have a 0, I have two factors, set them up, factor 1, factor 2. This one is already done. Now this one you may want to write a little work step here, and then maybe when you get to the end here, just sort of jump to the final answer. You know, sometimes you want to do partial work just to make sure you got it right. So my two answers are negative 4 and 0, and I'm going to write them in ascending order. All right, one more. Two factors equals 0, okay. All right. Now this one's a little bit weird. This hasn't happened before, so let's take a really close look at this. This says that 4 is equal to 0, and that absolutely is not true. So 4 is not an answer, and 0 is not an answer. You just have a statement here that's not true. So what we have to do is kind of like eliminate this whole idea over here, right? This is an implausible answer. It's not possible. So we're kind of going to ignore it. But you have to cross it out like this to really show that you understand that that sentence is irrelevant to your solution. Do a little math over here, and yes, this does happen sometimes. You might get a rational answer. So there's only one answer to this problem, and it is negative 5/2. Now you can certainly put that in the fancy brackets if you like. All right, so remember, if you come up with a false statement, you have to cross that out. You have to refute that answer. All right, I think you're ready to try 4 on your own. Pause the video and then check your responses. Okay, how did you do? All right, let's try some that are a little more challenging. All right, so this time I have something that's already in factored form, right? I have the quantity x plus 5 times the quantity x minus 3, and if their product is 0, then either this is equal to 0 or that is equal to 0. Well, this one's pretty fast, right? Do you need me to show the inverse operations? Here we go. Here we go. And the final answers are negative 5 and positive 3. That's it. Let's try another one. It does get harder than this. Okay, it's already factored. It's equal to 0. So let's start with our split. All right, I think you're doing okay. So I'm just going to write my answers here. Negative 7/2 and positive 4. Does that make sense to you? All right, great. All right, here's where it starts to get a little bit harder. It is equal to 0, but it's not in factored form. So there's actually two ways you could solve this. One is to understand that to square something means to multiply it by itself. So here are my two factors. So either x minus 8 is equal to 0 or x minus 8 is equal to 0. I think I wrote that already. right? Because they're repeating factors. So the answer here would be a single 8. If they both have the same answer, you write it one time. Does that make sense? All right, let me show you a different way. What if I wanted to eliminate this power of 2? Right? To eliminate a square means to take a square root. Now the only reason I can do that, even though there's a minus sign here, you're not allowed to do that. You're not allowed to take the square root of a multi-term sentence, but it's all part of one giant quantity. So technically this is one item. So I can take the square root of this whole side because this whole thing is being squared. So they would be inverses. And I can take the square root of 0 because that would be 0. And now I don't have two factors. So this one I'm not going to solve by factoring. I'm going to solve by using inverse operations only, which is a step I did in the beginning. The square was eliminated by using an inverse square root. And now the minus 8 is eliminated by using an inverse plus 8. I get the same answer as before. Okay? So sometimes you can just square root both sides. That works too. That even works if this number over here is not a 0, because we're not using the 0 product rule. Okay? All right. How about this one? Can I square root both sides? Yes. No. Right? We practiced this the other day. I can square root of 16, but I can't square root that. So that's not square rootable on both sides. So I think what I need to do is make sure that this is equal to 0. And you know how you do that? You manipulate your sentence and move that 16x over to the other side. If I subtract 16x from both sides, right, that's what I'm really doing, then this is what I would get. Which is great, but this is not factored. So the first thing I do is look to see if there's a GCF, right? And it looks like there is. If I factor out an x, I'd be left with x minus 16. And that is a factorization. So now, since I know the product is 0, I can set this up as two separate problems. So the solutions are 0 and positive 16. Right? I'm skipping the inverse step here, but I think you get it. All right, again, I cannot square root this side because there's a minus sign here, right? Now, that would be different than this, right? This is different. When this sentence is being squared, that's different than these both being perfect squares, okay? So don't confuse those two techniques. Well, I do have an equals 0, but I don't have any factors here. But that looks like a difference of two squares, right? So I'm going to factor this into a sum and difference. And I'm going to square root the first term, square root the last term, and now I have my two factors. Remember, you have to show me the split. You have to show me that this is one of your equations and that this is one of your equations. Any work after this is optional. So it looks like my two solutions are going to be -5 on my left side, +5 on my right side. And sometimes I've even seen this answer written like this. When the 5 digits match, but the signs are different, sometimes you'll see this little symbol here. It's called the plus-minus symbol, right? So the answer is plus or minus 5. Really, it means positive or -5. All right. Think you could do this one? Similar to the last one. Factor out a GCF. Set both factors equal to 0. Answer your problem. That's it. Okay. What do you think about this one? Well, I can't square root both sides because you cannot square root an x. So it looks like I'm going to have to manipulate this problem. 3x squared minus 12x equals 0. Factor out my GCF of 3 and x. Get x minus 4. Then set up my two separate equations. So 0 and 4. All right, it's your turn. Pause the video and give these 4 a try. All right, time to check your answers. All right, these are your final questions here. I want you to pause the video, write them down, and then check your final answers. Good luck. All right, ready to check these 8? Pause the video so you can check through all these answers. But if you think you're ready, why don't we end this off with a little exit ticket? Let's see if you can get these 2 right. Pretend it's like a little mini quiz. Pause the video now. All right, I bet you got them right. Great job.